Hello students, today we're going to take a look at vertical and projectile motion and maximum height combined together. So we're going to do both all in one scenario and question. So at the start here you got a little review. You got the formula for being measured, height measured in feet versus a height being measured in meters. So we have both those formulas there at the start and a review of the variables that go with it. All right, so let's take a look at number one. The soccer goalie is kicking or punting a ball, essentially, so not off the ground, because it says the starting height of the soccer ball is 4 feet. Its initial upward velocity is 48. So the velocity goes here, starting height is right here, and this one is actually given to us. So we've got A, B, and C, and we're going to try to decide when will the ball hit the ground. So this one's being kicked from 4 feet. It's going to go up, hit the ground here, and we're trying to find how long will it take on the x-axis for the ball to hit the ground. So that being said, so we're going to we're changing h to 0 because that's the height, the ending height. So that's why we can go ahead and do quadratic formula. If 0 is equal to the negative 16t squared plus 48t plus 4, that is why we plug in 0 and we can do quadratic formula. All right, so we're going to go t is equal to opposite of b plus and minus the square root of b squared, so 48 squared minus 4. A is negative 16 times c, which is 4. That whole thing is over 2 times a, which is negative 16. So there you go. Pause if you need to catch up on that part. We're going to use our calculator to find out what happens under the radical. When we do that, we should get 2,560 as it works out. Make sure you're careful with your parentheses and your signs under the radical. Whoops, on the bottom here we're going to get 2 times that, we get negative 32. So negative 32 under the radical, or sorry, under the division sign, so at the bottom of the denominator. All right, so then we take the square root of 2560. So t is equal to a negative 48 plus and minus, and we get about 50.60. So normally we round to 2 decimal places, but if you round it, it ends up 0.60, which is essentially 50.6. And we're still dividing by negative 32. Now when we do that, if we added the 50.6, because we got two numbers from the plus and minus, we get 2.6 divided by negative 32. Now that would have a negative outcome. We can't have a negative time here, so that one is out. Or what we could do is get negative 48 minus the 50.6. We get negative 98.6 over negative 32, and that will give us our answer here. When it would hit the ground would be at about or approximately 3.08 seconds. Don't forget to label that. So there you go. There's our work for when the ball would hit the ground. Now the next question is, when will it reach its maximum height? So that is, how long will it take to get from here to here? All right. So we're looking at this distance, or sorry, not distance, this time. So in this case, we get to do the mini quadratic formula. So we're going to do the opposite of b over, because we're trying to find the vertex, opposite of b over 2 times a, which is the negative 16. All right, so we always refer back to this formula. We get negative 48 over negative 32, and that's going to be a time of 1.5 seconds. So there is part B. Now, part B and C are linked together because we need to find the max height to find how high, or sorry, we need to find the time it takes. So right here is 1.5 seconds to find out how high was the ball at that time. So in order to get the height, so we're going to do h is equal to, we go back to the original right here, negative 16 times 1.5 squared. So we're going to plug in our new time, which is this one, not when it would hit the ball. When the ball hits the ground, the height is 0. When the ball reaches its max height is going to be this time that we found for the vertex. So plus 48 times 1.5 plus 4 there. And so really we're just using our calculator to calculate all of that and then multiply it all out. Be careful with the signs and the parentheses. And we should get right at about 40 feet. So how high does the ball go? That would be after 1.5 seconds, it's up 40 feet in the air. So feel free to pause there if you need to catch up. But that's page 68. All right, we're going to move along to number 2. This time an object is launched 22.3 meters per second from a 48.2 meter tall platform. All right, so if we want to draw a picture with this one, right, the platform is a little bit higher. It's at 48.2. And this is not, your picture doesn't have to be drawn to scale, and you guys don't have to draw this every time. I'm just trying to give you a visual of what's happening and what we're looking at. So this time it's launched up with the 22.3 meters per second. All right, so we're going to find a couple things. We're going to find when does it hit the ground. We're also, again, going to find how long until it reaches its max height. Those are parts B and C. So when it hits the ground, so basically, first of all, we got to write the equation. So this is meters. So this is going to be the formula where it's h is equal to negative 4.9 t squared. And then the velocity is the 22.3 meters per second. And then the starting height, so that's plus 48.2. So here is our formula. So we're going to have to get A, B, and C from that. Okay, so A being here, B being the 22.3, and C being the 48.2. Okay, so when does the ball hit the ground? Or it's not the ball this time. When does the object go down and hit the ground? So that's going to be when h is 0, starting height is 0, so we can do quadratic formula. So we're going to go t is equal to opposite of b, negative 22.3, plus and minus the square root of b squared, so 22.3 squared, minus 4 times a, the negative 4.9, times c, the 48.2. So we got all of that underneath the radical over 2 times a, the negative 4.9. All right, so we've got it all set up. Now we just got to use the calculator to plug everything in. Just be careful with the signs and the parentheses, but we're going to do everything under the radical to kind of break this into chunks. So under the radical, we'll see what we get. On the denominator, we get a negative 9.8. And under the radical, all that works out to about 1,442.01. So test that on your calculator if you're doing this at home. And so I rounded to 2 decimal places with that. Okay. Now from there, we're going to have to take the square root. So now t is going to equal negative 22.3 plus and minus. The square root of that is going to be about 37.97. So once you take the square root, the radical sign goes away. That whole thing is over negative 9.8 still. Now, when we go to combine these top parts, we've got 2 possible answers, but if one of them is a negative time, which we can't have, then that one we can basically eliminate. So if we try to do the negative 22.3 plus the 15, it's plus the 37, we end up getting about, I think it's 15.67 over negative 9.8. We would have negative time, so that one is out. Or, on the other hand, if we combine the negatives, negative 22.3 minus 37.97, that over here, 22.3 minus 37.97, that will still be over negative 9.8. For this one, we would get t is equal to, let's keep this over here separate, t is equal to a negative 60.27 over negative 9.8. And so our time here ends up being approximately 6.15 seconds. And again, use your calculator for that. Certainly don't have to do that in your head. But is that, you always ask yourself at the end, does it sound reasonable? I would say 6.1 seconds is pretty reasonable for the hang time, or for some projectile object to be in the air and come down and hit the ground, or the water, I guess, depending on where you're at. Could be a lot of different. Could be a golf ball. Could be all kinds of things you could come up with for that one. All right. So when will it reach its maximum height? So now, we answered this question of when it hits the ground. Now we got to find how long until it gets to here, and then how high is it? That's the link of part B and part C that are kind of go together. All right. So t is equal to the opposite of b, so negative 22.3 over 2 times a, the negative 4.9. All right, so really we're going to use our calculator here, but the negative 22.3 stays up there. Multiply that, we get negative 9.8, much like we did up there on the other one. And then just use your calculator, so our time for that should be about 2.28 seconds. That is seconds, not meters, because that answer is when will it reach it. So, which sounds reasonable. It's not quite halfway. It would reach its max height a little bit sooner because it's from so high up. That's why it's not quite halfway. And then how high does the object go? Like, what is the actual height? So we're going to take the 2.28 and plug it in. H is equal to negative 4.9 t squared plus 22.3 for the velocity plus the starting height of 48.2. Whoops. Instead of the t, we're going to plug in this 2.28. Okay, so it's going to go like that, plus 22.3. I gotta go in there and just copy down the equation. 2.28 goes in for the time of that one, plus the 48.2. So use your calculator, type it in exactly as I have it here. Make sure you use parentheses in the right spots, and we should end up with a height of about 73.57 meters. Make sure you label it as meters because it is a height, and that meters were what we had as far as the platform and so on. You want it to match up, so don't put feet on a question that has meters. So there you go. You can pause it if needed. We found that all these parts here, we found how long it takes to reach its max height was 2.28, and we found that the actual height, which is reasonable, if it's an upward velocity, approximately 73.57 meters is a good height that could go with this. So if you get a crazy answer, like you get 1,000 meters high, then that, obviously something's off. Or if you get something that's below this, something's off. So you can check that way. All right, so those are the two main questions. We got one more kind of special scenario. This one, we have a child sets a tennis ball down, and we've got a ramp. Okay, so my ramp's not perfect, but they set the ball down right here. Obviously, this could continue, but we're looking at right here for the y-axis. Okay, and then we're trying to find. Let's see. The child sets the ball down at the top of an 8 meter tall ramp. All right, and if they just set it down and the ball starts rolling this way, okay, we got to write the equation and then find out obviously a couple answers. So the equation here, it's in meters, so it's going to be negative 4.9 t squared. All right, and then the initial velocity, if they just set it down, they're not pushing it, they're just setting it down, and it's on a slope or a ramp, so the initial velocity is 0. Okay, and so that's what's kind of unique about this one. The starting height was 8. So the initial velocity, you could even leave this out and just write it as negative 4.9 t squared plus 8, because the 0 would just go away. So how many seconds will it take for the ball to hit the ground? So that is essentially what we're going to do. 0 is equal to negative 4.9 t squared plus 8. So if you're thinking of A, B, and C, though, we have to account for B as 0. All right, and that's because there's nothing times t there. It's just plus 8. So we've got A and C. So we're going to do quadratic formula. So t is equal to, the opposite of b is just 0. So you can put positive or negative 0, it doesn't matter. Then we've got 0 squared minus 4. A is negative 4.9 times c is 8. Okay, that all will be over 2 times a, which is negative 4.9 here. So use your calculator. The zeros make this go a little faster. So we get the 0 we don't even need to write there. We're going to have plus and minus. That 0 goes away. I believe we get 156.8 if you round it under the radical. And then the denominator, we get negative 9.8 again. So we can pull this up over here. So we take the square root of both, or we're not the square root of both. You could get positive or negative here of 12.52. So positive 12.52 over negative 9.8, whoops, 0.8, or negative 12.52 over negative 9.8. Because this would be a negative time, we can't have that. So the negative negative turns into a positive, and we get 1.28 seconds. So that's how long the ball, if we just started or not just set it down and it rolls down the ramp, it would gain speed as it's going down and end up, according to this, we'd be about 1.28 seconds. Now, when is the ball at its maximum height? Well, it's not going up, so we're actually right here is actually, so for this one, the ball is at its maximum height of 8 feet. Okay, so we could plug things in, like we could do opposite of b over 2a, but the height is 8 feet, so that would be at 0 seconds. So at 0 seconds, that would be our answer there, because the height is 8 feet. And we could certainly work this out, but really don't overthink this last part. It's just basically asking, its maximum height is right at the start, so it's 0 seconds right here. Because it doesn't go up, having a picture can kind of help on that. All right, so if you have questions, certainly reach out on Canvas. Feel free to pause at any point to catch up on the note taking, and make sure to practice with the calculator as you go along on these so we have a good understanding of that. So hope everyone has a great day, and again, reach out if you have any questions.